Good afternoon, folks. Amplifier experts working on a Marantz 240 that has been to another repair shop and was originally recapped by a repair shop. Customer received the amplifier and it worked for about a half an hour, and then something happened and smoke came out and the amplifier ceased to function. When we got the amplifier in, we found no shorted transistors on either channel, so we brought it up on a variac, found out that the left channel was working fine because we could monitor it at the output of the Zobel network, which was just ahead of the speaker protection relay. That's a location right about here. Actually, there was a convenient terminal where we could access this point and see an audio signal there with relatively little zero to little DC offset. So the left channel was working. The right channel, however, was stuck at rail potential, positive rail potential. So we began to investigate further, found no shorts anywhere, went all the way back to the beginning, and no shorted transistors. Ohmmeter check was good. Started checking resistors, no open resistors at the time. And after a lot of troubleshooting, we also discovered that the shop that had worked on it had installed a replacement for Q506 in backwards. So we corrected that. However, the amplifier still did not work. It was still putting out plus DC rail at the Zobel network. So we continued to troubleshoot. And what was eventually discovered was that Q516 had gone open. Collector emitter junction was open. We took this transistor out, tested it on a curve tracer, and it didn't produce any curves. And how we figured Q516? Well, Q516 controls the bias on Q505, which provides bias to the pre-driver transistors. This was wrong. This was sitting up at rail potential. So we automatically came to the conclusion there must be a problem here. So we pulled this transistor and tested it, and sure enough, it was open. Opens are much harder to find than shorts for obvious reasons, because in circuit, an ohmmeter will find a short, but how do you find an open? Because there are other components around that will provide resistance and bypass the open transistor. So we replaced this transistor with a suitable high voltage rated modern substitute, and we brought the amplifier up on a variac. Didn't have any DC offset here. That was a good sign. So we brought the amplifier the rest of the way up with the intention of running signal through it. Before we got up to full line voltage, the speaker protection relay actually engaged, and that meant that all was good as far as DC offsets on the outputs of both channels. So at this point, we figured this is it. We got the problem licked, and we brought the variac up to full line. But then this resistor here, R529, a 1 watt 39 ohm resistor, went up in smoke. And then we looked across these output transistors, and all four of them were shorted. So naturally you have the WTF moment of, well, if it was working with 60 to 70 volts line voltage, why would it suddenly fail at full line voltage? So we did a little closer looking at the heatsink and the transistors as we pulled them out, and we realized, according to this schematic, these were supposed to be the P junction transistors and these are supposed to be the N junction. However, the shop that had replaced the output transistors put the N junctions up here and the P junctions down here. Well, we didn't know that. And so, as a result, all 4 of these transistors popped, taking this resistor with it. So new resistors and transistors are on order. Should be here Wednesday. And we'll put them in the proper way. And hopefully this amplifier will work again.